Today we're going to be looking at adding and subtracting rational expressions that do not have like denominators. Let's look at this lesson opener. Notice we have fractions that are not in common denominators, and we need to put them in common denominators in order to add or subtract them. We already know how to do that. In this top problem, our common denominator is going to be 6. And in this bottom problem, our common denominator is going to be 8. You know how to do that. And whenever we go ahead and solve the problems, we end up with 1/6 and 5/8. Let's look at the next one. Let's think about the top one. Our common denominator, our least common denominator is going to be 12, although you might have used 24 also. In this one, our least common denominator is going to be 15. And when we subtract the top one, we get -1/12, and when we add the bottom one, we get 19/15. That is an improper fraction, but that's okay. It's fine to leave it like that. Now, when we look at this negative fraction, we could also write this like this, or just with our negative sign out in the front. If any part of that fraction is negative, then the whole fraction is negative. Let's look at this one. Let's think about our least common denominator. And this is not one that we just know off the top of our heads. So we might need to actually figure it out by doing the greatest common factor. Or no, not the greatest common factor, the least common multiple. Or the greatest common factor, either one. We could use either way to figure out our least common denominator. I believe that our least common denominator is going to be 42. Because 14 times 3 is 42, and 21 times 2 is 42. So when we solve this problem, we end up with 19/42. So when we add or subtract, we always have to put it in a common denominator. Very first thing, that's the first thing we have to do. And in order to find our common denominator, we look at the least common multiple of the two denominators. You can use your prime factorization on your calculator to help you with that. And then just to review how to find the least common denominator, you actually circle the highest or the biggest of each number that is shown in the two prime factorizations. And then you multiply those two together, or those numbers together. So let's find the least common multiple of these two expressions. Now this does not look like what we're used to seeing. In our x to the 4th minus 3x to the 3rd minus 10x squared, if we notice, none of our numbers actually have anything in common, but we do all have x's. So we're going to choose the largest that's in common. The thing that we can take out of everything is our x squared. When we look at this expression, we actually have 3's in common. 3 can go into each of these numbers, and we also have 1x that can come out of each. So what we do for this first one is we think about the fact that our x squared can come out. We kind of skipped ahead here. Let's think about this for a minute. We have x squared comes out. That makes our first term be x squared, and our second term be 3x, and our third term be 10. Then we go ahead and factor this, and it will become this with x squared on the outside. For our second term, we actually have the 3 in common, and that is going to become 3, oh, we have a 3x in common. That is going to become 3x and then x squared minus 10x plus 25. And then we factor that, which becomes x minus 5 squared, or x minus 5 times x minus 5. So whenever we look at both of these expressions, our least common multiple for both expressions, we use what we took out and we circle the biggest of each. So we have a 3 and we have an x squared, just like we did before, and we end up with 3x squared. Okay, here's a problem that's more like what we're used to seeing. We need to think about our common denominator for 2a and 8. And if we think about that, 2 goes into 8, and so we could change both of these very easily into 8a. And we just think about what we have to do in order to change them. In order to change this into 8a, we have to multiply it by 4. Whatever we do to the denominator, we have to do to the numerator, so we would have to multiply that. In order to make this one into 8a, we multiply by a. Whatever we do to the denominator, we have to do to the numerator. So then we end up with 4 times 3 and 4 times 2a for our first problem, which plus 5 times a and 8 times a for our second problem. And we cannot combine our 12 and our 5a because they're unlike terms, so we just simply end up with 5a plus 12 over 8a. Now, if you switch these, that's okay. We just generally put that variable first, and we put the number without a variable second. And that's just a normal procedure, so that's why we switched it in our final answer. Let's look at another example. This time we have 3 numbers. And just looking at this, we have a 3, a 2, and a 12. I believe that 12 is going to be our common denominator, and we need to think about our x's. We have an x, and an x squared. So I think it all needs to turn out to be 12x squared. Then we just look, this is already in 12x squared. We need to look at these two and think about what we have to multiply to make it become 12x squared. And just like any fraction, whatever we do to the denominator, we need to do to the numerator. So in our first problem, we need to multiply everything by 4x. And in our second problem, we need to multiply everything by 6x. Remember, if you want this x to become squared, you have to multiply it by another x. So that's why we have to make these have x's in them, so that they'll be x squared. And then our third problem stays the same because the denominator was already the way it needed to be. Now we can go ahead and distribute our 4x and our 6x. And then we will combine like terms all over the denominator of 12x squared. Okay, let's look at this example. These two denominators do not have anything in common. When you have two denominators that do not have anything in common, you can multiply them and they can become the common denominator. So our least common denominator becomes x plus 1 times x plus 2. And whenever we go ahead and convert our first fraction, we come up with this, and whenever we convert our second fraction, this is what we come up with. Okay, so let's go ahead and look here. We need to go ahead and use FOIL to combine our numerators. We're just going to leave the denominator how it is. And let's go ahead and combine our like terms, and we end up with 2 times x minus 2. We can still factor some out of this, and if we notice, we can actually factor out the 2. These are very similar, and later on in your maths you'll learn how to actually change those so that you can cancel some stuff out and simplify this even more. But for today we're going to go ahead and leave it like that. Okay, so these denominators are pretty similar, but just a little bit different. If I made this be squared and this be squared, it would be pretty similar. Let's think about what we might be able to do to this. If we factor this a out and this b out, we would have the same denominators. So let's go ahead and look at it that way. We have an AB times the a plus b. And we need to actually go ahead and multiply whatever we need to multiply in order to make that happen in the numerator, just like we have to in the denominator. And then we can combine like terms. A BB is the same as B squared, and AA is the same as A squared. These are not like terms, so we just leave them like that and subtract them, put them all over the one denominator. We can go ahead and factor these out. Notice we have B plus A and A plus B. Those are the same because commutative property says that we can change addition problems back and forth without changing the actual answer. So they cancel out, and we're left with B minus A over AB. So when we're adding and subtracting, let's just recap. We first find the least common denominator of the rational expressions. We make equivalent expressions by multiplying the numerator by the same thing we had to multiply the denominator by. And then we combine the numerators and put them over the common denominator and simplify the rational expression by either canceling or reducing